أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله. Welcome to our lecture 6. In this lecture we will start a new chapter where we will start with electrostatic principle, where we will discuss about all the static forces and the field strength related to all the static electric charges. So let's go to our slides. Okay, here we will first talk about the electrostatic force, but these all electrostatic forces actually they are related to electrostatic field actually. So that by the definition it says that if there are two different charges, then there will be, because each of the charge will have their corresponding field around it. Let's say this is a positive charge and this is negative charge, and they will have their corresponding field around it. So this charge have a field around this, and the positive charge have a field around like this. So, and due to these two different charges having the two different fields, they will try to attract or detract. Means if it's opposite charges, then they will attract, and if it's same charges, like same polarity, means plus plus or minus minus, then it will detract. However, we will discuss that in details in the later upcoming slides. But for the beginner, we can talk about that anything which is stationary, means a charge which is not moving, and that moving charge when it will impact on another charge, then there will be a force between them. So due to the Coulomb's law, we can actually determine the forces between these two charges. So let's go to the next slide. This is what we call the Coulomb's law. The Coulomb's law states that if there are two different charges, so there will be a force between them along the line of the joining them, means this line directly, not like this, no, it will be direct force between these two. Either it can be attracting force, or it can be repelling or detracting force also. So there the Coulomb's law actually states that the first statement I already told, that the force will be along the joining of them, line joining them. The second one is it is directly proportional to the amount of the multiplication of the two different charges. Means the Q1 and Q2, it have to be multiplied together. So the force is proportional to the multiplication of the Q1 and Q2, or the big Q1 and Q2. So this one. And then it is inversely proportional to the square of the distance between them, which is r. If it's r, it can be small r, it can be big r, it can be p, it can be s, it can be t, whatever. But the main thing is the distance between these two. So the inversely proportional to the square of the distance between Q1 and Q2. So here, if the proportional sign we take it out, then actually I am not elaborating it too much, because we need to take we don't need to go for direct derivation. So we can write actually based on this three principle, that F is equal to K Q1 multiplied by Q2 divided by R square. where k is the constant, which is this value 1 by 1 over 4 pi epsilon naught, where the epsilon naught value is this one or this one. Okay, and the k value you directly can calculate, which is 9 multiplied by 10 to the power 9 meter per farad. So it is like an opposite of force. I think it's force. You can call Newton actually. This one. So Newton per meter, something like this. So, however, remember this one is. I think I'm wrong. This is supposed to be farad, I believe. Farad per meter, I think, because this is related to charge. So, but don't care about this. So here, remember one thing is F is equal to 1 over 4 pi epsilon Q1 multiplied by Q2 divided by R square Newton. Newton is the unit of the force. So, but this is simple, you know from the physics, actually from the SPM. But now we put this one into a 3D space. Once we put it in the 3D rectangular space, it somehow look like this. So here it's a Q1 charge, and this is a Q2 charge, and there is a distance between them is, we know that from origin, we know from our previous classes that from origin the position vector is of Q2 is R2 and the position vector of Q1 is R1, because position vector is always from the origin. Now the distance between them is R2 minus R1, which is actually R. So now we know this is R and this is R1 and this is R2. So the force of from Q1 to Q2, so from Q1 to Q2 you can write force of F12 is equal to Q1 multiplied by Q2 divided by 4 pi epsilon naught R square, and there will be one unit vector always, as what I said always, that will be one unit vector towards R12. Okay, so this towards this one, the distance of the R12, the unit vector. So how you calculate the unit vector? You calculate the unit vector means this unit vector divided by the value of this unit vector, isn't it? So here you check, there are some things I put here. So Q1 you know already, which is Coulomb. Okay, here is the force, the vector force on Q2, means on Q2 due to Q1. So if you find the vector force on Q1 due to Q2, this will become 2, 1. Now we R1 and R2, we know the vector location of Q1 and Q2, what I said already, and the R12 is this one, R2 minus R1. So the R is equal to the optimum, the modulus value of R2 and 1. We know it. I'm not going to elaborate that much. So the A, the unit vector of R12 is the value of R12 divided by the R. So value of the R12 is this divided by R. R is, so this one divided by this. So like that, if you consider this one, if you put the value of here, then it becomes somehow like this, because R square will be below, and then we R will be below here. So AR12 is equal to what? This one divided by this one, right? So this R will multiply with this R, becomes R cube, and this is just like this. But this one we know that R2 minus R1. So this is the new formula of the vector force between Q1 and Q2. So you remember not only this one, you need to remember this, that if you want to find force between Q1 and Q2, Q1 and Q2, then you have to find the distance, and then you need to cube it, and the vector of the distance vector, and then the value of Q1 and Q2, and divided by 4 pi epsilon naught. So this all the things are here. I hope you understand this one. So continuing with this one is, there can be 4 different scenarios here, that there will be 2 positive charges. So one positive charge, another positive charge will repel each other. So if this charge is bigger than this one, then this force will be higher, and if this charge is bigger than this one, so this force will be higher. Now it can be both negative, and the same scenario applies here. So it will repel from each other, means it will try to go away from each other. So if this is higher than this one, so this force will be higher than this one, and if this is higher than this one, so this force, the pushing force, will be higher than this one. Now similar way, if the left side positive and right side negative, then there will be an attraction, and also this is the same. So there can be 4 different criteria. So now this is, so far we have learned about 2 charges, right? Now what will happen, that if there are many charges, because we only learned about the Q2, what is the charge of Q2 due to charge, what is the force on Q2 due to the charge Q1. Now if you try to find out there are many charges, what will happen? So then we will apply the identity of summation. In mathematics, possibly you know it. However, let me first demonstrate what is going on here. The charge Q1, let's say there is a charge Q, and there are so many charges surrounded by charges like Q1, Q2, Q3, Q4, and so on, and so many charges after Qn. Means Qn number of charges are surrounding the Q charges. So we want to find out the effect of all the charges on Q2. Means the force, total vector force on Q, this Q, due to all the different charges. So what we need to do is, it's quite similar, that this one, what we find based on Q1, right, we find the due to the vector force on Q2 due to Q1, right? Now let's say if it's Q3, then would have been another force here, right? So we just add. So here there are Q1, Q2, Q3, Q4, Q5, and so on and so forth. What we will do, we will individually calculate the force of Q1, on the Q due to Q1, and then we will find the force. So this is like F1, and then we will find the force on Q due to Q2, and then we will find on Q due to Q3, and then so on. We will find force on Q due to Qn. So all the individual forces, F1, F2, F3, F5, will be added, and then we will get the real value. So this is like this. So we will find the Q due to Q, due to Q1 on Q, due to Q2 on Q, and so on, and then we will add them, and then we will get this final value, final equation. And the final equation is the summation of Q, this one, the charge, the main charge, the Q, and the 4 pi epsilon And the summation of k is equal to 1, means from q1, q2, q3, this with this value, varying these values 1, 2, 3, 4, it will determine the q1, q2, q3, q4 and so on. Summation of n, and qk means it will follow this k value and then this. And it will also follow the k. If it's k1, then it becomes q1, r1, r1. If it's k2, this becomes q2, it will represent this. If it's k3, then becomes q3, r minus r3, and this is r3. It's like this. So this is so far the electric force due to multiple point charge and due to single point charge. Now we go and discuss about the electric field. So an electric field, what is an electric field? Electric field can be called the electric field intensity or electric field strength also. It's the same thing. Okay, the electric field is actually it's I already told you in the beginning of our lecture actually, that the energy surrounded by of any charge is actually the field. So it can be two different charges can have different fields. You know, it depends on the charge distribution. Later on we will talk about it. But let's say you talk about this one and this one. So both they have their field surrounded of their individual charges, right? Let's go to more deeply like this. So this is positive charge, right? So positive charge have its electric field surround it, and the negative charge also have an electric field surround it. Even though they are actually attracting, but it is actually due to their field. Now, based on this one, actually, we can write something like this, that E, the electric field or electric field strength, is equal to F, means the force between these two divided by Q. And then also for this one also same, the force between these two divided by Q, which is actually takes away, if you go back here, so we have two Q's, right? So if you divide it with the Q, then one Q goes away. So only Q1 left. So like this you can write that E is equal to only 1Q 4 pi epsilon R R square AR, and then this is the final one. So E is equal to this one, Q R minus R dash, or R1 or R2, R3, R4, whatever you can write, 4 pi divided by 4 pi epsilon R minus R dash. So remember this one. Now if similarly it's the same way that if there are so many charges, it will follow the same equation like the force equation, and the unit of this one is volt per meter. Now you read these things a little bit. I have explained it here. Now what is the difference between these two? You can check here. So electric force is equal to Q 4 pi epsilon summation QK multiplied by R minus RK divided by R K cube, right? And then this is mostly similar, but there is Q missing, that's all. So it is these are the same thing, but for F you need two charges, but for E you don't need any charges. If only one charge is given, you can actually directly calculate the electric field intensity or electric field strength. So for this force, this is Newton in Newton, and this is Newton per meter. We call it also volt per meter. So with this actually I will try to conclude the theory part here. In the next video, the second part of our lecture, I will start with doing some examples. and then we will move on with different charge distribution and so on. So assalamu alaikum wa rahmatullah. See you in the next part.